Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today I'm going to cover several topics. You might want to get yourself a beverage and come on back and watch the whole thing straight through. I think the video might run half an hour, 45 minutes. You never know. I tend to ramble. So, hope you enjoyed that answer. Stick with me on Patreon. We're getting very close to some soaring flights. I know, sounds very exciting. Right now, I have it rumbling in my head that I might be able to do some soaring at Marina Beach. And I got more to talk about on that further on in the video here. So, take a little break here. This might be where you want to hit pause and go refresh your beverage. And I'm going to stop the camera for a second, have some water, and I'm going to wipe well, maybe I'll leave this up on the board. We'll see. And I'm going to talk about the recent tests that we had. Okay, welcome back. Hope you had a little refresher there, and I'll talk for a moment about tests down at Marina Beach. I'll start off by putting up a picture here. I guess I'll put it over here, of me standing behind the wing, talking to George and Jim. These are two of my local helpers. George is out of Los Altos and Jim is out of the Santa Cruz Hills. And they're both hang glider pilots, been around for decades, they know their stuff, and they came out to help that day, and I just want to give them a special note of thanks, because without their help and input, and I'm going to talk about Jim's input here in a little bit and how important it is, I wouldn't be able to do what I'm doing. And not shown is Dave Duff, a longtime friend of mine. I've known him for decades, and he shot the picture, which I thought was a nice picture because it doesn't show my face and it shows the two helpers, which is really what's most important. And you see me standing right next to the new elevons. You've probably looked at the photos of building those elevons, and boy, was that a tough build. I don't recommend it for anybody. I gotta find a better way to build those things. Really difficult to get that 3.5 degrees of twist in them precisely. But I built them, they're on there. They're not, they won't win any beauty contests, but they work. And we got out with them, and the flow stays nicely attached, as expected. And the flow begins to separate up around 25 degrees. And just like I said in the previous part, relying on observed results, that's exactly what I expected to see from previous tests that I've done with a flat plate trailing edge control surface, is that they're good to about 25 degrees and then the flow starts to separate. So the controls were generally set up to have a maximum throw of 30 degrees. I figured I'd tolerate a little bit of flow separation just so I get plenty of throw for both elevator and aileron functions, and that worked out reasonably well. We did have one little hiccup along the way, and I'll talk about that in a minute. But generally, those new control surfaces are fabulous. The wing now handles a lot like my original wing. I have feedback on the stick, I can feel the controls. Part of that was I had to remove a couple of cable guides from inside the wing that were close to the bell crank. They were creating drag as I got near maximum throw. They were not hanging up, but they got very draggy. So by removing those guides, those are now free to run. So I can get feedback at the stick, and the roll rates are just lovely. I would say right now the ailerons are absolutely perfect in terms of sensitivity. Very easy to handle the wing on the ground, no longer a struggle. And I would say I probably have 3 times the roll rate than I've had in the past. And that's with the control surfaces only inboard of the winglet, which is great because remember, the concept is to not have any control surface outboard of the winglet, so that if the control surfaces are deflected up and we're trying to shove the air out towards the wingtip, the winglet stops that from happening. And the wingtips, by not having any control surfaces on them, the flow is always chordwise and stays attached. And from previous tests, we've seen those results, that the flow inboard of the winglets can be going absolutely crazy, but the wingtip panels are still flying. So this setup with the elevons as flat plates on the trailing edge and the size that I made them worked out great. Super. Don't need control surfaces out on those wingtip panels. It's great. And besides, it keeps the CG from going too far aft. Anyway, so thanks again to Jim and George for coming out, and I'm sure they'll come out for some future discussions. And right now I'd like to run a little bit of video for you showing me doing the ground handling of the wing. It's very short. And what you should note is I'm standing there having a conversation with Jim while I'm flying the wing. And the wing's carrying maybe a third of my weight, something like that. And I don't even have to think about it. You know, for me, it's very, as a pilot, it's very natural. I'm not even thinking about flying the wing. I'm talking to Jim and we're having a conversation and my hand's doing whatever it needs to do to keep flying that wing. And that is a great thing to have, that if you have an experienced pilot, he doesn't have to put a lot of thought into what he's doing. It's in the muscle memory. Now for me, that's after decades of flying. But if anybody's a decent stick and rudder pilot, they'd be able to handle this wing. It's a lot like my original wing. It is just peachy. Now, the elevators are still not quite sensitive enough. I wish they were a little bit more sensitive, but they are okay. And it's something, it's a tweak that I'll deal with at a later date. So the even throw bell cranks that I changed out for the differential throw ones, much better. And the larger elevons and as flat plates on the trailing edge are just working super. And we made a lot of runs that day down the hill without flying, you know, just flying the wing at near stall speed, lifting my weight for the most part. And what's it fly like? And it flies great. I really like the wing now. And if you think of some of the older videos, you'll see me hunched over and I'm struggling, and I've always edited out the parts where I go, oh, I haven't got it, I haven't got it. And guys would run over and grab the pilot's cage and pull it back down and get me straightened up again. So all of the previous foot launching stuff was a struggle until I got the wing stabilized and then hurry up and run. It's not the case anymore. I can fly it right on takeoff. Now we did have one incident. Now in this video, the wind is blowing 12 to 15 miles an hour, and there are gusts coming through that are close to 20. So on a regular hang glider, that would be a challenging day. For me, it was pretty easy until we had one gust come through and it shoved me off to the right, and I put in, or it shoved me off to the left, and I put in down and right stick and exceeded the 30-degree deflection on the control surface, and the flow separated. And once the flow separated, oh, I got massive adverse yaw, and I lost control of the wing, and they had to grab me and pull me back over. Now, we can't let that happen in real life when we're getting ready for a flight, so I'm gonna have to make sure that I restrict the control surface throws to 30 degrees. But that should be plenty for flying this wing. And what I'm gonna do with the mixer or the control horns remains to be seen. But in the meantime, I'll just adjust the push rods at the elevons to prevent them from traveling so far. Other than that, easy to handle. In fact, it was so easy, on our last run down the hill, I was able to, near the end of the run, and oh, by the way, the lifeguard station is there. So we really couldn't fly because the wind was coming right from the lifeguard station. I'm running straight at the lifeguard station, and I have to do all of this before we get there, and then they grab the pilot's cage and stop me before I ram into anything. But right at the very end, I was able to just pop in full up elevator and pick up my feet, and I was up and flying. It was that easy. And very short flight. I flew maybe 20 feet. Wings very stable, easy to fly. She's ready to go. So except for limiting the throw of the control surfaces, that glider's ready to fly. Now, in the process, I did note, well, actually, let's go watch the video, and then I'll come back and I'll talk a bit more about how the glider was handling while we were there. So I'm going to spin you around, we'll go over to the other video. I'll talk over that video a little bit.
So as you can hear, the wind is really cranking, and there I am talking to Jim and just flying the glider. Wind's blowing pretty close to about 17 miles an hour here. It might be gusting to 20. And if you look in the background, you'll see a windsock that's sticking straight out. And that tells you that that wind is really honking through there. There's no other hang gliders flying this day. And maybe the conditions were too strong for them, but I'm doing just fine.
Okay, so we're back. Hope you enjoyed that little video. Thanks, Dave, for shooting it. Nice video. Anyway, so the way that the wing handled initially was it was unstable in pitch. I didn't have the harness on. I wasn't hooked in because we didn't want to take that risk. What if you have a blowover? You know, you lose the glider, that's one thing, but we don't want to lose me. And that's typical for how I test this stuff. I don't necessarily strap in right away. So I recognized that we're tail heavy. And remember, I had mentioned in the past that, maybe the problem we had at El Mirage was not a lack of control throw or a lack of control power, but we had an aft CG situation. And I'm now beginning to think that that's true, because when we were at Marina Beach, I was hooked in at the normal hook-in point, and the glider was tail heavy. In fact, it had gone so tail heavy, now had negative static margin on it. It was either neutral or negative, because without my weight on it, without my weight pulling the nose back down, you'd be there perfectly stable, all of a sudden the nose would go down like this, and gust of wind coming in and go back up the other way. And if I was really fast on the stick, I could keep up with it, but it was a little spooky. As soon as I was in the harness and strapped in and we're running down the hill, very stable. As soon as my weight was on there, because my weight's forward of the empty CG. So the empty CG is now too far aft, and it moved back quite a bit because of those elevons I stuck on the trailing edge. They're fairly heavy, it's about 5 pounds, put right on the trailing edge. And they've moved the CG aft, so I have to have my weight on the glider in order to get into a positive static margin condition. That said, I'll be modifying the wing, as you know, to remove the hinges from the old control surfaces and building new wingtips that are lighter. So I'm hoping that all of those changes will get the empty CG back forward to at least a neutrally stable configuration, be a little easier to handle on the ground, and don't have to worry about this pitchiness up and down until, which only exists until it's lifting some of my weight. That'll make it ground handling even easier then. So there was that also. So right now we know that empty, the glider's a little tail heavy, and I'm guessing there is some situation that we don't fully understand, the difference between towing it and how I'm reclining in that situation, and when I'm standing to fly it in a foot launch in the CG setup, such that when we were in El Mirage, it was probably either neutrally stable or slightly unstable. And I was quick enough on the stick to keep up with it, but when you're unstable like that, you can easily run out of control throw and not have enough to recover. So it's a good thing I got off a tow right away. And that was another clue. When I got off a tow, the nose immediately went back down. I pulled in up elevator, the nose shot up and stalled, and then I mushed in. And that's indicative of an unstable configuration. So my buddy Bob finally revealed the details that he has an electronic aircraft weight and balance system. Who knew? Apparently it's got 4 scales and so forth, but this next week we're going to go to his hangar at Reed Hillview in San Jose. We're going to put the glider together in the hangar, and we're going to put it on this system, and I'm going to be in the glider and we're going to do both configurations, the foot launch configuration and the towing configuration, and get the actual CG locations and see if we can figure out what actually is going on to make such a difference between foot launch and towing. Because we were very careful when we went and towed. We measured where my belly button was. We said that's where the CG is, and this and that. And we made the calculation. We go, static margin's fine. Got 5%. Well, we had like 4.6% static margin, which is fine. And it should have flown fine at El Mirage. I shouldn't have been that touchy on pitch, but it was. So we'll rely on the observed results. Is that it was a little pitchy at El Mirage. In fact, it was so pitchy I couldn't really control it. And we'll go do weight and balance on it. And George said, "Oh yeah, that'd be a good idea." And then Peter says, "Well, it's more than a good idea, it's essential." Have to get that work done first before we go out and fly again. But we are ready to fly. And I'll loop back around here. 1 second, while I take a sip here. We'll probably edit this out. So let me loop back to Jim. Jim is a very wonderful, calm character. And he builds kayaks, flies hang gliders. Interesting fellow. But he's very level-headed, very calm, and he communicates in a different way. Some friends I have will tell me to go pound sand and say why an idea is stupid, and other people will just ignore me. But Jim's an interesting guy. If he has an idea, he doesn't slam it at you. It's like slipping a note under the door. It's very subtle. Slips it in there, And if you pick it up and read it, great. You might get something out of it. So during when I'm handling this on launch and I'm flying in place, we're having a conversation. And then later on, when I'm talking to him and George, he's dropping a few more hints. And he had to say it several times. He said, half a dozen times probably, if we only had 20-mile-an-hour wind. The first thing he asked me, he says, "What's your stall speed?" And he says, "Do you know your stall speed?" I said, "Yeah, we've measured it and have it on video, and it's 23 miles an hour." He said, "Oh, good. If we only had 20 miles an hour, you could just float here in place." He says, "Up at the top of the hill." And he didn't say it, but what he was saying is, well, we wouldn't have to worry about the guard shack or the lifeguard station because I wouldn't be going anywhere. I could just hop it off the ground and float it there, and they could stand next to me and walk with me if I move forward and pull me down if they need to pull me down. And I says, "Yeah, but we only have 15. He goes, "Yeah, but it might blow 20 later today," and it was supposed to. And the whitecaps were offshore. The 20 miles an hour was offshore, but it never made it onshore for a variety of weather conditions. We never got the 20. And it's like, oh, too bad, And it's like, well, as I got home, it was probably the next day. It's like, oh, wait, Jim was trying to tell me something. He didn't say it directly. He said it in some sideways fashion. So I don't know, maybe he didn't really mean to tell me this. But he put all the pieces there that I could put together and go, oh, that's what we do. If I could fly slow enough, there's lots of days at Marina Beach where it blows 15 miles an hour. If I could get my stall speed down to close to 15 miles per hour, then I could fly it in place. We wouldn't have to sit there and wait for that, once a month day where it blows 20. Now, the benefit of blowing 20 is that there's no other hang gliders there, so I get the whole place to myself. However, being able to fly it down to 15 miles an hour would be even better. And if I could just take off at the top of the hill and float it in place, I can get lots of stick time on this thing. And, little gusts will come through, and I'll go one way, I'll come back the other way, and I'll just fly it in place. And when I'm done, I yell at the guys that are standing next to me to pull me down because I'm only going to be 3 or 4 feet off the ground. And then we go through a series of those, and actually, if it worked out okay, the top of the hill is about 50, 60 feet above the lifeguard station, above the top of the lifeguard station. So if I take off and drop my left wing and scoot sideways like this, I don't have to make a turn. I just have to skid sideways, get a little bit of yaw set up there and drop a wing and let the whole thing drift to my left. I can literally fly behind the lifeguard station above its roof and just avoid it entirely. And all I have to do is fly the gap that's there from the takeoff to the ridge, which is maybe 100 yards, a little less. Sorry, I had to take a little break there to go get a power cable for the camera. Ran out of battery juice because I rambled. So anyway, so it dawned on me I might be able to soar there at Marina Beach if the winds are strong enough and I can get my stall speed down. And you say, hey, Raul, what kind of magic you got in your pocket now that somehow magically this design that you created that has a stall speed of 23 miles an hour with your tubby little belly on board, how do you drop that from 23 down to 15 or 17? And see, that's when the pieces all came together for me, is that I realized, oh, I'm doing these slotted flaps. I'm going to test them. I'm building a temporary set of flaps out of foam core board with a slot in to figure it out, see how it works. And in theory, slotted flaps will increase your maximum lift coefficient, the sectional lift coefficient, by a factor of 2. Like you can go from maximum lift coefficient 1.6 up to 3.2, that would be. 3.2 and maybe a little more. Now that's only 20 some odd percent of my wing, but is it enough to make a difference? And I did a couple of the back on the envelope calculations, and it's like just enough. It's on the hairy edge. So these slotted flaps might lower my stall speed down into the 17 mile an hour range, which would be great. So then, on one of those days where we got steady 15 and maybe gusting 20, I'll be able to launch at the top of the hill, fly behind and above the lifeguard station, and on down to the ridge. And that ridge runs several miles all the way down to Sand City. And I'd probably just make one run. I would just fly straight on down the ridge. Sand City has a really wide beach, nice and flat, and I'd land there. And then they'd pull the trailer down and come pick me up. So it could be a fantastic flight, and I think it's possible because when I was on the short hop that I had, now it's only 20 feet, but my brain collects a lot of data while I'm flying, and all I realized was I had no data to collect. There was nothing unusual going on. I was flying a regular sailplane, just like all the other sailplanes that I've flown in. It was a perfectly normal aircraft. And, you know, I wish I had some video to show you of that flight, but we set up the camera up on the winglet and we were ready to get video of that little hop when the memory cards went full. And we don't have that, unfortunately. And this is once again the problem of RAW and electronics. We're not the best of friends. That's why I had to go get a cable to charge up the batteries here. Just mechanical stuff, I'm there. Electronics, a little spacey on that. So, sorry we don't have that video. Next one, we'll get you. Plenty of video of it flying. So, really, all of this is good news. If the slotted flaps are as good as I think they're going to be, we're going to have fabulous news, and I'll be up and soaring that thing before you know it. In fact, I was so encouraged that I'm off modifying the landing gear, the temporary stuff that I had for operating at the beach, those 3 big balloon tires. I'm converting that. I'm still going to use one of them, but I'm going to have one wheel behind me and a smaller wheel up front, as was the original design. And I'm going to set these up such that it's high enough up off the ground so that I can just squat and pick the thing up. And we noted that, you know, if the wind's blowing 10, you pull in full up elevator, it just flies itself up off the ground. It's very easy. So I'm going to get into a configuration that's much more what was intended to be flown. For me to make that kind of commitment to go do that modification means that I'm pretty confident about how this thing is handling and flying. Now, that said, we still have the whole CG thing. So once Bob helps me sort out the CG location, I should have the flaps done by then, and get the new wheel set up on there. We'll be good to go, and I won't need the sawhorses anymore. You know, it's getting a little old to bend all the way down to the ground and get the glider up. So I was using those sawhorses, but I think they'll be able to go away. It'll just sit on its landing gear. I'll be able to bend down and pick it up. So all great improvements. We're looking forward to having some fabulous flights. And Jim was there promoting that the first soaring flight be at Big Sur because the landing area is huge. But I think that accidentally or maybe on purpose, he put all the seeds in there that says, oh, we can do it at Marina Beach. Which I like, because if anything goes wrong, you crash on the sand. And given my options, I'd rather crash on sand than just about anywhere else. So keep your fingers crossed, and I think we've got some great stuff coming. So all of that said, third segment here, we're going to talk about the air data system, and I'm going to show you a little bit more video, and that'll take a little while, so maybe you want to take a break here, go get a beverage, come back, and hear the rest of the video. Okay, here we are. Air data collection system. Looks like nothing but a bunch of electronic parts in a food storage container. They're in the food storage container because we were at Marina Beach and I didn't want sand getting in my electronics. You know, pop the lid on here and not a problem. But there's the main component here is the flight computer, which is right here, this box. And this has a full IMU in it. It has 3 accelerometers, 3 gyros, 3 compasses. It has everything that you need to keep track of what the aircraft is doing. Pitch, yaw, roll, and so forth. And it has inputs for other components, such as the hockey puck thing here. This is GPS, so I know where I am, even though I already know where I am. But the GPS helps with all of the data. And it has telemetry. This is an optional extra. You have this little antenna here. This is 915 megahertz, and it broadcasts for up to like 3 miles, which is fabulous. I mean, this little tiny thing that costs $55, and it can do 3 miles, and it's frequency hopping, and it can be encrypted. So really high-end stuff. I used to work in a world where everything that this does was classified, but not anymore. Now it's all out in the open. And then on the receiving side, you get a bigger antenna like this, and this can plug in to your laptop. so you can collect the data as it comes in. Now the data is stored, the data from the flight is stored on board the flight computer, and it's also sent over the telemetry, so you have it at both ends. And there's other stuff you can plug in here, like the airspeed. I got a pitot tube with static ports, a standard item off the shelf, and here's the actual airspeed itself. It's this little chip right here, and it has static and dynamic ports, and it plugs into the board, and it gives you airspeed. And you'll see in a moment here that all of this data goes in, gets sent to a program called Mission Planner. And Mission Planner gives you a full head-up display, just like you'd have in a modern glass cockpit aircraft. Or you can switch it over and put up steam dial gauges, you know, the old-fashioned style, which is what I like. And you'll see that in the video. So that's kind of cool to have. And it has a little annunciator on here that makes noises when it goes into various modes and flashing lights, and it's all very pretty. And of course I got a switch on here so we can turn it on and off from outside the box. And you can run it off of one of these drone batteries like this 11.1 volt drone battery. This battery size here will run it for about 10 hours. It's great, and it easily fits in the box, not a problem. Or if you use the USB port that's on the side of this, there's a little USB port on the side, which is both a power and data port. And you plug in something to that, it will run off of that. So if you have a laptop plugged in here or a tablet, it pulls power from that. And actually you can set both up. You can pull power from the tablet and have a battery, and you got plenty of juice to carry you all day long. So what I've done is I got me a handy dandy 8-inch tablet here. This is the Samsung Galaxy, and it has a USB 2.0 port on the bottom. So it has data and power. So this is my glass cockpit. I'm probably the first hang glider on the planet to have a full glass cockpit, because this will give me GPS for navigation, and it gives me all of the flight data right in front of my face. I'll get altitude, airspeed, rate of climb, and there's a whole bunch of other instruments that I can choose from and configure it. In fact, I grant you the software, the Mission Planner, is really deep software. You can control every parameter, and if you're like me, you can screw it up pretty quick and thoroughly. But anyway, I keep it in its basic mode. I got a little clamp on the back here. I bought this tablet mount for bicycles. This is meant for people that are going nowhere, the people that ride those stationary bikes, and maybe I should do some of that, but they don't go anywhere, and I like to go places, more fun. But anyway, this will clamp onto the pilot's cage frame, and then I put the display up here, and I can either do it this way or I can do it this way, and I have my flight instruments here. And I suspect it'll be like probably right over there like that, so I can see ahead, but I can glance over here and get my flight information when I get it all working. Now, that said, it is me, and it's taken a while to get all this stuff to work consistently. There are two basic systems out there. There's the other system that's SpeedyBee. Really meant, this system is really meant for quadcopters. The other system is meant for fixed-wing drones. And SpeedyBee uses software called iNav, and I know a little bit about it, but not enough to say any specifics about which is better, which is worse. Hugely competitive online right now as to who's got the better system. But overall, both systems cost about the same. This whole setup, I got the tablet for 69 bucks off of Amazon. It's a renewed one. If I was going to be out in the sand, I didn't want anything brand spanking new and expensive. And the rest of this, all put together, less than $300. Okay, so a very affordable air data system. It's going to be a lot of fun and to play with and get us some interesting data. And let me show you some of the stuff that I get as output from that system. We're going to go look at a little video clip here. It's a split screen. On one side, you're going to see the nominal display from the air data system, and on the other screen, you're going to see one of the winglets, and you'll see a series of black marks on the winglet mount, and that is so that we can see how much deflection the elevons are going through as I ground handle and go through a takeoff run. And this video is actually from that first hop. Unfortunately, the video runs out when the cards go full before I took off. You'll see two segments. I run forward a little bit and pause, and we talk about it, and then I say, let's go again from where we are, and we go, and then the video ends. However, we did get data for the entire trip, and what you'll see you'll see an overhead display of me on the sand dune, walking around, going side to side and forward and so forth, and then you'll see me run forward a little and then run forward again. Now, on the downside, the air data system had data drop out. So I actually couldn't get the two screens synchronized. So what you see on the winglet and what you see on the air data, it's the same flight, but they're not synchronized because of the data dropout on the air data system. But you get an idea how it works and what I'm going to see in the cockpit and what we're going to be able to analyze further down the road. One little factor that you might want to note is that just by happenstance, they use Google Maps, of course, and by happenstance, when the satellite took its last picture of Marina Beach, my wing was there. My wing was in the picture, and you've probably seen the short little video I put up about that. So you're going to see my wing sitting there on the beach, not going anywhere. Well, that's because it's a solid picture from Google Maps, and I'm actually the little red airplane that's moving around. So it's a little disconcerting at first. And the other hang glider that you see there, that's not really there either. That's on the Google Maps. We were the only people out there that day. And it's just a little weird to say, hey, there's Raul's wing, and then it doesn't move, and the little red airplane runs forward. And why is it doing that? And that's because the Google Map is a little bit of a lie, so to speak. But anyway, let's go take a look at that video.
Okay, what we see on the left here is the basic display that I'll have on my tablet in the cockpit, glass display. On the left hand side we see the head-up display that shows me my pitch angle and roll angle and heading. On the left is also airspeed, and I forget what's on the right. Below you see the regular dial gauges, the old-fashioned stuff, and they're set up right now for airspeed, rate of climb, altitude, and heading. You can make any of these screens smaller or larger. I generally make the instruments considerably larger and put the head-up display over the GPS display. Part of this is the GPS is on the right half of that screen. Little red airplane is me, and as I told you, the old Google map picture of my wing it happens to be underlaid. You'll see me sidestep a little bit. That's not to get around the other glider because that glider's not there. I'm just managing the wind conditions. And then I make a short little jaunt forward and stand there for a while and think about it. Then I make another run forward. And on the right-hand side, you'll watch the elevon move up and down, and if you have it on a big enough screen, you'll see some of the angles, and I just thought it was interesting. But the two are not synchronized together. Sorry about that. There was no way to get that done.
Anyway, welcome back. I hope you enjoyed that little clip. There wasn't a whole lot to see there, but it's just kind of interesting to see the air data system working. And even though I think I run straight down the hill, it's really not quite straight. And you saw how the instruments are set up there. So it's going to be cool to have this in the cockpit with me. And I look forward to flying with it, and we'll see how well it works out. I am working rapidly right now to make the modifications on the glider. It's probably going to be another month before we go out. 3 weeks, probably at the earliest. And of course, it's going to be weather dependent. And you keep watching for that video, and I think it's going to be pretty exciting. And I'm really looking forward to it. So I'm going to get back in the shop here tonight, and I'm going to work on a couple of things with the landing gear. And in the meantime, I will tell you, fly safe and bye for now.